In this lecture, we'll discuss about the worked examples on series and parallel circuit. So before solving the problems, we'll discuss the formula used here. We'll consider a series circuit in which R1, R2 and R3 are the three resistors connected in series. Here VDC is the supply voltage, DC supply voltage, and IDC is the current flowing through the series circuit. VR1, VR2 and VR3 are the voltage drop across the resistors R1, R2 and R3 respectively. In the case of a series circuit, the current always remains the same. That is, the same current will flow through all the three resistors. Whereas the voltage divides. Okay. Here the total voltage is VDC and the voltages across each resistor is VR1, VR2 and VR3. So we can add all the voltages up. Okay, VDC is equal to VR1 plus VR2 plus VR3. If suppose n number of resistors are connected in series, then we have to write plus and so on up to Vn. That is, we have to add all the other voltage drops also, like VR4, VR5, etc. and so on up to V suffix n. Next, the total resistance value is given by sum of all the resistors connected in series. So if we consider three resistances, then the total resistance RT is equal to R1 plus R2 plus R3. If we consider n number of resistors, then sum of all the resistors up to nth resistance. So next we can apply voltage division rule for finding out the voltage drop across each resistor. Okay. So here by voltage division rule, VR1 is given by the total voltage VDC multiplied by the same value of the resistance R1 divided by sum of all the resistors. Okay. Similarly, VR2 VDC into same value of resistance R2 divided by sum of all the resistors, and VR3 is equal to VDC into R3 divided by sum of all the resistors. Okay, here we have to multiply the total voltage with the same value of the resistor. So next we'll discuss the parallel circuit. So let us consider three resistances connected in parallel. So if it is a parallel circuit, then both the upper end of the resistors and lower ends of the resistors will be connected together. So here VDC is the supply voltage and IT is the total current flowing through the circuit. Here the voltage will remain the same. Whereas current gets divided as I1, I2 and I3. So now we can write IT is equal to I1 plus I2 plus I3 if we are considering three resistors. And if n number of resistors are connected, then we have to add all the currents up to IN. And similarly, the total resistance or equivalent resistance is given by 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected, then we have to add all the resistors, reciprocals of all the resistors till the nth resistance. If suppose two resistors are connected in parallel, then we have to write 1 by RT is equal to 1 by R1 plus 1 by R2. Okay. So now if we take R1 and R2 as a common denominator, in the numerator we have R2 plus R1. So in the left hand side we have 1 by RT. On the right hand side we have R1 plus R2 or R2 plus R1 divided by R1 R2. So now taking reciprocals on both sides, we'll get RT. So RT value will be equal to R1 R2. So if we take reciprocal, this term will come to the numerator and the numerator term will come to the denominator. So R1 R2 divided by R1 plus R2 is the total resistance. So if if we consider two resistors in parallel, then we can write RT directly as R1 R2 divided by R1 plus R2. Then we can apply the current division rule. So if we are considering two resistances in parallel, then current flowing through a particular branch, say current flowing through the resistor R1. So here let us forget this R3. Now we are considering only R1 and R2. So if we want to find out I1, then we have to multiply the total current IT with the opposite value of the resistor. So this is the resistor which is connected in parallel to R1. Okay, so this is the opposite resistor value. IT into R2 divided by sum of the resistors R1 plus R2. Similarly, if we want to find I2 is equal to total current IT multiplied by opposite resistance value, here in this case R1, divided by sum of the resistors. So now if we consider all these three resistors connected in parallel, then I1 can be written as the total current multiplied by opposite value of resistor. So if you see here, two resistances R2 and R3 are connected opposite to R1, and that too these two resistors are connected in parallel. So if we simplify these two resistors into a single value, then we can apply this formula. Okay, two resistors are connected, the total resistance is given by R1 R2 divided by R1 plus R2. So here R2 and R3 are connected in parallel. If we reduce this into an equivalent resistance, then it can be written as R2 R3 divided by R2 plus R3. So this combination is connected in parallel with R1, right? So this will constitute the opposite value of resistor. So opposite value of resistor multiplied by IT divided by sum of all the resistors. Okay. Similarly, I2 can be written as IT multiplied by the opposite value of resistors. So if we consider this R2, here the opposite branches are R1 and R3 connected in parallel. So if we simplify these two resistors, then we can write R1 R3 divided by R1 plus R3 whole divided by R1 plus R2 plus R3. So these are the related formulae which we are going to use for solving the problems. So first one, three resistances R1, R2 and R3 are connected in series to a 240 volts DC source as given in figure 1. Okay, this is the circuit given. Here three resistances R1, R2 and R3 are connected in series across a voltage source of 240 volts. Okay, so if R1 is equal to 50 ohms, VR2 is equal to 60 volts and current flowing through the circuit is 0.5 ampere, calculate the values of the resistances R2 and R3. So here R1 value is given and voltage drop across R2 is also given. We have to find out R2 and R3. Okay. So first we have to write the given data. So VDC supply voltage is equal to 240 volts, R1 resistance 50 ohms, VR2 voltage drop across the resistor R2 is 60 volts and the total current IDC is equal to 0.5 ampere. So now in the case of a series circuit, as already discussed, this current will remain the same. Okay, the same current will flow through R1, R2 as well as R3. So now here we have the current flowing through R2 and also we have the voltage. So if we apply Ohm's law to this branch, we can find out the R2 value. VR2 is equal to IDC into R2, this is Ohm's law. So then R2 can be written as VR2 divided by IC. Okay, so VR2 is equal to 60, IDC is 0.5. So R2 can be written as 60 by 0.5, that is equal to 120 ohms. Okay, this is the R2 value. We have found out the resistor R2. So now we have to find out R3 value. So here we do not know the voltage drop. Okay, instead we can find out the total value of resistance over here, because we are given with the total voltage and total current. So we can find out the total resistance, and we also know that the total resistance RT is given by R1 plus R2 plus R3. So once we find out the total resistance, we can easily find out the value of R3, because R1 already given, R2 we have found out here. Okay, so now we'll find out the total resistance RT by applying same Ohm's law. By Ohm's law, VDC is equal to IDC into RT. Total voltage is equal to total current into total resistance. RT is equal to VDC by IDC, 240 by 0.5, that is equal to 480 ohms. So now in a series circuit, RT is equal to R1 plus R2 plus R3. So we'll substitute all the values. RT is equal to 480, R1 50, R2 120. So we can easily find out the value of R3. So if we add these two, we'll get 170. So here we have 480. So if we subtract 170 from 480, that is 480 minus 170, we'll get 310. So this is the required value of R3. Now the second question. Two 60 ohms resistances are connected in series. So here two 60 ohms resistors are connected in series. So here one resistor, here another resistor. When a resistance R is connected across any one of them, the total circuit resistance is 70 ohms. Calculate the value of R. So here we'll consider that the unknown value is connected across the second resistor. Okay, here R is connected across means in parallel. Okay, connected across means connected in parallel. So let us consider these two are in parallel. Now the total resistance or the equivalent resistance of this combination is 70 ohms. Okay. So now we have to find out the value of R. So let us consider the same circuit here. So these two are connected in parallel because both the ends are connected together. See here, left hand side also connected and the right hand side is also connected. Then these two resistors are connected in parallel. So for a parallel circuit or a parallel resistance, we know that the total resistance is R1 R2 divided by R1 plus R2. So in a similar way, we can write 60 into R divided by 60 plus R. So let us consider this combination as R2 and let this be R1. Now the total resistance value is given, that is R1 plus R2 is given. So we can write it as R1 plus R2 is equal to 70. So we all know this is connected in series. Okay, only one end is connected. Okay, this R1 and R2 are connected in series whose value is 70. So now we'll substitute these values. 60 plus 60R divided by 60 plus R is equal to 70. So now we can take this 60 towards the right hand side. So this plus 60 will become minus 60. So on the left hand side we have 60R divided by 60 plus R. On the right hand side 70 minus 60 is equal to 10. So now we can cross multiply these 60 plus R with 10. So here we have 60R is equal to 10 into 60 plus R. So now if we multiply inside, 10 into 60 is 600, 10 into R is 10R. On the left hand side we have 60R. So now we can bring this plus 10R towards the left hand side. So it will become minus. So 60R minus 10R, that will be equal to 600. So 60R minus 10R is 50R. 50R is 600. R is equal to 600 by 50, that is equal to 12 ohms. So this is the required answer. So next, third question. So this is again a series parallel combination of resistors, right? So the question is, find the equivalent resistance between the 2 points P and Q for the circuit shown in figure 3. So this is the circuit. So let us consider the same circuit over here. So now we have to reduce all the resistors into its equivalent single resistance value. Now these three resistors are connected in parallel. Okay, both the ends of all the resistors are connected together. So if we simplify it, then we know this formula, 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we can apply the formula here, 1 by 4 plus 1 by 5 plus 1 by 5. Okay, this is the R equivalent or the total resistance. So after simplification, we have to take reciprocals on both sides. Okay. So now this is the circuit. These three resistors get reduced into a single value. Okay. So on solving the previous equation, we will get 1.538 ohms. Okay. So these three resistors are replaced by 1.538. We can draw the equivalent here. Okay, 3 ohms is connected in series with 1.38. Similarly, 6 ohms and 7 ohms are connected in series. So rest of the resistors are 2 ohms and 8 ohms. They will remain as such. Okay. So now we can reduce these two. So we know that in the case of a series circuit, the resistors, total resistance is given by sum of the resistors. So we can add these two, 3 plus 1.538, so that will be equal to 4.538. So here 6 plus 7, that is equal to 13. So 8 and 2 will remain the same. So now these three resistors are connected in parallel. Both the ends are connected together. So now we can find out the equivalent resistance by applying the same formula. 1 by RT is equal to 1 by 4.538 plus 1 by 13 plus 1 by 8. On simplification, we will get 2.368. So now these three resistors get converted into a single equivalent, 2.368. Now finally, these two resistors are connected in series and we can add them. 2 plus 2.368, that is equal to 4.368 ohms. So this is the required answer. So next one, reduce the given network shown in the figure 4 to a single equivalent resistance across the terminals P and Q. So this is also a similar problem. So if we have to find out the equivalent resistance across the terminals P and Q. So if we want to find out the equivalent resistance from these two terminals, then we have to start solving from the opposite direction. Okay, that is, so in this case we have to start solving from here. Okay, so we should not disturb these 2 points. So now let us consider the same circuit. So here 7 ohms and 13 ohms are connected in parallel. Both the upper end as well as the lower ends are connected. So now this can be simplified into a single equivalent resistance. 1 by total resistance is equal to 1 by 7 plus 1 by 13. So once you simplify this term, we have to take the reciprocal. Okay. So you simplify this and take the reciprocal so that we will get the total resistance value. So that will be equal to 4.55. So now we have to replace these two resistors into a single equivalent 4.55. Now we can redraw the circuit like this. 7 ohms, 4.55, 10, 4 ohms and 4 ohms. So now these two resistors are connected in series. Only one end is connected together. Other ends are connected to the other element. So these two are connected in series. So the total resistance is given by 7 plus 4.5 or 4.55 plus 7. So we have to add these two. So the answer is 11.55. So now again we can redraw the circuit like this. 4 ohms, 10 ohms and 4 ohms will remain as such. These two resistors are replaced by 11.55. Okay. So now again if you see here, these two are connected in parallel because both the upper end and lower ends are connected. So these two are parallel. Then we can reduce them into a single equivalent resistance by using this formula. 1 by R equivalent is equal to 1 by 11.55 plus 1 by 10. So after simplifying this term, you have to take the reciprocal. Don't forget to take the reciprocal. So R equivalent is equal to 5.359 ohms. Okay. So now finally the equivalent circuit got reduced like this. 3 resistors connected in series. So if we have 3 resistors connected in series, then the equivalent resistance is given by 4 plus 4 plus 5.359, that is equal to 13.359 ohms. Okay, this is the required value of equivalent resistance across P and Q. Now the next problem, find the magnitude of the total current through R1 and R2 if R1 is equal to 20 ohms, R2 is equal to 30 ohms and VDC is equal to 60 volts using current division rule. So we have to apply current division rule for finding out the values of I1 and I2. So here R1 value is given 20 ohms, R2 value is also given 30 ohms and the supply voltage VDC is given 60 volts. So now if you want to apply current division rule, we have to know the total current. So we have to find out the total current. Total current is equal to total voltage divided by total resistances. So total voltage is given. So we have to find out the total resistance value. So 20 and 30 are the resistors connected in parallel. Okay. So the total resistance is given by 1 by 20 plus 1 by 30. So we'll get RT is equal to 12 ohms. So now we can find out the current value. So total current is given by VDC by RT 60 by 12, that is equal to 5 ampere. So now we can apply the current division rule. So by current division rule, if we want to find out I1, so this is given by the total current multiplied by opposite value of resistor divided by sum of the resistors. So here opposite resistor is R2. R2 value is 30 ohms. IT already we have found out 5 ampere. So we can substitute them. 5 into 30 divided by 20 plus 30, that is equal to 3 ampere. Similarly, I2 is equal to total current multiplied by opposite resistor, that is R1 divided by sum of the resistors. So here also we can directly apply the values. So 5 into 20 divided by 20 plus 30. So that is equal to 2 ampere. So now we'll solve some gate questions. So the first one is all the resistances in the figure 6 or 1 ohm each. The value of I will be. Okay, we have to find out the value of current. The voltage is given 1 ohm, and these are the series and parallel combination of resistances. So here the options given are 1 by 15, 2 by 15, 4 by 15 and 8 by 15. Okay. So let us consider the circuit here. So if you see here, these two resistors are connected in parallel because both the ends of the resistors are connected together. So left hand side end is also connected. Similarly, right hand side is also connected together. Similarly, these two are connected in parallel. Again, this is parallel and this is also in parallel. Okay, all these are connected individually as a parallel connection. So we can simplify them by using the formula. Okay, we already know that the total resistance in a series circuit is given by R1 R2 divided by R1 plus R2. Here the values are same, 1 ohm. So we can substitute here 1 into 1 divided by 1 plus 1 is equal to 1 by 2, that is equal to 0.5 ohm. Okay. So these two resistors are converted into a single equivalent of 0.5 ohm. So now we can redraw the circuit as shown here. So these resistors are 1 ohm each. So we have to write 1 ohm each over here. These two are simplified as 0.5 each. So here 0.5, 0.5, 0.5 and again 0.5. So now these two resistors are connected in series. So these two are connected in series. These two are again connected in series, and finally these two are also in series. So in a series circuit, the total resistance is given by sum of all the resistors. So here we can add these two. 1 plus 0.5 will be 1.5. So here also 1.5. Here again 1.5, and finally here also 1.5. Now the circuit gets reduced like this. Okay. So this is 1.5, this is 1.5, this is 1.5, and this is also 1.5. Okay. So now these two resistors are connected again in parallel, and similarly these two are connected in parallel because both the ends are connected together, this end as well as this end. Okay. So again we can simplify them using the same formula, R1 into R2 divided by R1 plus R2. So 1.5 into 1.5 divided by 1.5 plus 1.5, that is equal to 0.75. Okay. So these two resistors are converted into a single equivalent of 0.75 ohm. So now we can redraw the circuit. So this is 1, this is 1, and this is 1. So now these two are reduced into 0.75 ohm. Okay, we can redraw like this. Now again these two resistors are connected in series. Okay, so now we can simplify them by simply adding these two resistors, 1 plus 0.75, 1.75 ohms, again 1 plus 0.75, 1.75 ohm. Okay, So now the circuit can be redrawn like this. This 1 ohm resistor will remain as such. These two will become 1.75. Okay. Again, these two resistors are connected in parallel. So we can apply the same formula like this, and we can simplify them into a single equivalent resistor. Okay, 1.75 into 1.75 divided by 1.75 plus 1.75, that will give you 0.825 ohms. Okay, so now we have 1 ohms connected in series with this 0.825 ohms resistor. Okay, so we can redraw the circuit like this: 1 ohm and 0.875. So these two resistors are connected in series. So the total resistance is given by 1 plus 0.875, that is 1.875. So now our aim is to find out the value of current. Here the total voltage is 1 volts and total resistance is 1.875 ohms. So now we can apply Ohm's law for getting the current. I is equal to V by R. 1 divided by 1.875, that is equal to 0.533 ampere. So if we convert them into a fraction value, it comes around 8 by 15 ampere. Okay, 8 upon 15 ampere is the answer. Now second question is in the figure 7. So this is figure 7. The current the current 1 ampere flows through the resistance of these are the options: 20 ohms, 4 ohms, 30 ohms and 12 ohms. So we have to find out through which value of the resistor 1 ampere current is flowing for the circuit shown in the figure. So here again, this is also a series parallel combination of resistors. So now we will consider the circuit over here. So here these two are connected in parallel. Okay, let us consider them as RT1, and again these three are connected in parallel. So let this be RT2, and finally these two are connected in parallel. Let this be RT3. Okay, so now we can find out the equivalent resistance or the total resistance: RT1, RT2 and RT3. Now RT1 is the parallel combination of 20 and 30. So we can write it as 20 into 30 divided by 20 plus 30, that is equal to 12 ohms. Okay. Similarly, we have to find out RT2 value. So 1 by RT2 is equal to 1 by 6 plus 1 by 4 plus 1 by 12. So 1 by 6 is 0.16667, 1 by 4 is 0.25, 1 by 12 is 0.08333. Okay. So we have to add all these things. So we will get 0.5 ohms. On the left hand side we have 1 by RT2. So we have to take reciprocals on both sides. So we can write RT2 is equal to 1 by 0.5, that is equal to 2 ohms. Similarly, we have to find out RT3 value. RT3 is nothing but the parallel combination of 10 and 15 ohms resistor. So RT3 can be written as 10 into 15 divided by 10 plus 15, that is equal to 6 ohms. Okay. So now the total resistance RT is given by RT1 plus RT2 plus RT3. Okay, if we see here, these combination can be reduced into a single equivalent resistances of 12 ohms, 6 ohms and again 2 ohms. Okay, 12, 2 and 6. Okay, these are the three resistors connected in series. So the total resistance will be equal to 20 ohms. Okay, so now we can find out the total current. So total current I is equal to total voltage divided by total resistance, 120 divided by 20, so that is equal to 6 ampere. So now we know the total resistance value. We also know the total current. So now we have to find out through which value of resistor 1 ampere current is flowing. Okay. So now we can redraw this like this: 12 ohms, 2 ohms and 6 ohms. Okay. So this is RT1, RT2 and RT3. So now we will find out the voltage drop across each resistor by using Ohm's law only, because we know the current flowing through the resistor as well as the resistance value also. So now the voltage drop across this RT1 resistor is given by VRT1 is equal to 12 into 6. Resistance value 12, current value 6. So V is equal to I into R. 6 into 12 or 12 into 6, that is equal to 72 volts. Similarly, VRT2. VRT2 is voltage drop across 2 ohms resistor. So current value 6, resistance value 2. So 6 into 2 or 2 into 6, 12 volts. Next VRT3. So VRT3 is the voltage drop across 6 ohms resistor. So current through the 6 ohms is 6 ampere. So V is equal to I into R. 6 into 6, that is equal to 36 volts. Okay. So now this is the equivalent circuit for this original circuit. Okay, this is the original circuit. Here we have 2 parallel combination of resistors. Here 3 parallel combination, and again here 2 parallel combination of resistors. Okay. So now we know that the voltage drop across these 2 parallel combinations 72 volts. Here this is 12 volts and here this is 36. So already we have found out VRT1, VRT2 and VRT3. Okay. So now we have to verify through which resistor 1 ampere current is flowing. Okay, now we know the resistance value, we know the voltage drop. So these two are connected in parallel, so the voltage will remain the same. So the voltage across 20 as well as 30 ohms resistor is 72 volts. Now if we want to find out the current value, then we have to divide this voltage by the resistor. V by R. I is equal to V by R. So 72 by 20 will not be equal to 1. Similarly, 72 divided by 30 will not be equal to 1 ampere. So we have to check through which value of resistor 1 ampere current is flowing. Okay. Similarly, if we see here, the voltage drop across 6 ohms resistor is 12 volts. So I is equal to 12 divided by 6, that is not equal to 1 ampere. Okay. Similarly, 12 divided by 4 is also not equal to 1. So again 12 divided by 12. So 12 divided by 12 will be equal to 1 ampere. So this 1 ampere of current is flowing through this 12 ohms resistor. So next, third one, the voltage E0 in the figure 8 is dash. So this is the fill in the blank. This is the figure 8. Okay, we have to find out the voltage drop across this 4 ohms resistor by simplifying this circuit. Okay, so the voltage is given and all the resistance values are given. So now let us consider this circuit again. So these two resistances, 2 ohms and 2 ohms, are connected in series. Okay, series means one end will be connected together, other ends are connected to some other elements. So these two can be added together. Okay, the total resistance value will be 2 plus 2. Okay, 4 ohms. So now the circuit can be redrawn like this. So already we have 4 ohms and 4 ohms. Now these 2 ohms connected in series are reduced into a single equivalent of 4 ohms. So if you see here, these two resistors are connected in parallel because both the upper end as well as the lower ends are connected. So this is a parallel combination of resistors. So now we can reduce them into a single value by using the same formula, R1 into R2 divided by R1 plus R2. So 4 into 4 divided by 4 plus 4, that is equal to 16 by 8 or 2 ohms. So we can reduce the circuit. Okay, 4 ohms, and this is reduced into a single equivalent of 2 ohms. Okay, so now we can apply voltage division rule. Now our aim is to find out the voltage drop across this 2 ohms resistor. So 2 ohms is nothing but the equivalent resistance of 2 4 ohms resistors connected in parallel. Okay, we have to find out the voltage drop across 4 ohms resistor in the original circuit. Okay, now we have reduced them into 4 ohms and 2 ohms connected in series. So now we can apply voltage division rule for finding out the voltage drop across this particular resistor. So the formula is, if we want to find out the voltage drop across this particular resistor, then we have to multiply the total voltage with the same value of resistor. Okay, so here the total voltage is 12, the same value of resistor 2 ohms divided by sum of the resistors 4 plus 2. Okay, so if you remember the formula, V2 can be written as VDC into R2 divided by R1 plus R2. So this can be considered as R1, this can be considered as R2. Okay, so 12 into 2 divided by 4 plus 2, that is equal to 24 by 6 or 4 volts.